Experimental comparison of AC and DC voltages. To investigate and compare AC and DC voltages, we have two circuits set up, an AC and a DC circuit. In the AC circuit, we have a mains power supply, which powers the bulb when this switch is set to A. Switching the switch to position B means that the bulb is now powered by the DC supply, which is made up of battery boards. This voltage can be controlled by a rheostat. In the centre, we have a cathode ray oscilloscope, which monitors the voltage across the bulb for each circuit orientation. Currently, it is measuring for the DC supply, and now the AC. We also have a light meter above the bulb, which we will later use to compare the brightness of the bulb for both circuits and therefore compare both AC and DC voltages. With the switch set to position A, such that the lamp is powered by the AC supply, we can measure the peak voltage of the oscilloscope. We have the oscilloscope set to 2 volts per division, so it looks like we have a peak voltage of 4.5 volts. So a peak voltage of 4.5 volts. We can then use the light meter to get a reading for the light intensity of the lamp at this voltage. So it is around 1500 lux. 1500 lux. We then move the switch to position B so that the lamp is powered by the DC supply. We will adjust the rheostat until the brightness of the lamp gives the same light intensity reading as for the AC supply. So that at 1500 lux. We'll again look at the oscilloscope to see what our voltage is. So it looks like our voltage is 3.2 volts from the DC supply. So 3.2 volts. So we can look at the ratio of the RMS voltage to the peak voltage for an AC supply by using our DC voltage in exchange for our RMS AC voltage. So the ratio of DC voltage to peak voltage is 3.2 over 4.5, which equals 0.71 repeating, which is roughly equal to a factor of 1 over root 2. And then we can say for an AC supply that RMS voltage equals the peak voltage divided by root 2.